All right, let's see if we can't wrap up section 2.5 with variations. I sent out the handout with the email to these links. So if you want to follow along on your screen, take notes. But it's a type of model where we can make a relationship between two things, like speed and braking distance. But there's also something called a constant of variation, and we tend to talk to it about K. So looking through our quick little box, it says let X and Y denote two quantities. Then Y, the first line varies with X, or Y is directly proportional. So your first line is varies. And it says if there is a non-zero number K for which exists. So our first line varies, exists. The number is K called constant, a variation. There's your three lines in the first box. But let's actually get into the nitty-gritty. We have two different types of variations. We have direct and inverse, or inversely. And most of your problems are going to state that. Usually we'll start out with Y is directly proportional with something, and they'll tell you about the X. But it's not always X and Y. But let's talk first, what is the basic? Well, when we're directly across. Straight across. When we're inversely, we're not. So those are your two bases. Now, sometimes they're going to give you letters for Y and X, and then you just replace it. But the K is always a value that you're going to have to calculate. So if they tell you to calculate the constant of variation, they're telling you to calculate the K. So looking at example 1, it says construct a model. At Kevin's hourly job, his monthly paycheck varies directly with the number of hours he works. Well, we got pay and hours worked. And yes, I do expect you to tell me what the letters mean. I can use Y and X, or I could use P and H. It's still going to fall under that sentence. If you notice it, I'm going to erase. The term is directly. So in this very first one, the paycheck varies directly with. So the paycheck is the Y with the hours worked. So right there is our very basis. But you notice in part A, it says relates to paycheck P. So that means they're telling me what my letters are. So I'm going to replace. It's not telling me about the H or the hours worked, so I'm going to leave it as X. But last month he worked 82 hours and earned 963.50. What do you think they gave me that for? Well, if I plug in what I know, I can solve for what I don't know. So 82 hours work, that would be my X. The reason I said, go ahead and tell me what the letters, it helps. I don't know what my K is. But I do know 82 hours is my hours worked. And my pay, 963.50. Well, I'm sitting here looking around. And now I solve K. Simple enough. So how do I solve K? I divide both sides by 82. And we get constant 1175. Well, guess what? 1175 is how much it makes. So to state the actual equation, it's P equals 11.75x. We found K. And it says, what does the K value represent in the context of this problem? How much he makes per hour. But it's the constant of variation. It's a proper name. So it says, using my model, determine what his pay would be if he worked only 52 hours. What do you think? I'm going to use my new model, and I'm going to plug in 52 for my X, because X represents hours worked. And I'm keying into my handy dandy calculator. And Kevin's going to make $611. What do you think? Straightforward enough? All right. So again, same basic box. Let's look at example 2. Example 2 tells us inverse variation. So remember back on page 1, inverse looks like something like this. So the demand for a popular new phone varies inversely. So I have new phone varies inversely with the cost. So phone to cost. When the retail price of the phone is $199, the retailer can sell 7,200 units. This time they're saying write the model P for phone and D for the units sold per month. No, I wrote that backwards. I'm sitting there reading that. Demand for new phones, reason why they're calling it D. I hate it when they use cost and then turn around and say price. Sorry. So we lead with the phone, demand for phones. So that would be my Y. The part that is to the left of the word inverse or direct is the Y portion. So we have a D equals K over B. And again, they're giving me price and the unit number of units. Well, number of units would be the demand, don't you think? So we plug in. So we plugged in for what we know, what they gave us. And how do you get something off the bottom of a fraction? You multiply by it. So I multiply both sides by 199. And I get K equals, wow, that's a big K. That's what it is. And I got the 199 off the bottom of the fraction by multiplying. So what is my new equation? Well, my new equation is D equals there we go. That's part A. Part B wants us to solve for what would happen if the price was decreased to 150. Well, I'm going to erase a little bit. Hopefully you don't need this anymore. So if the price is 150, means I plug in for the P. And solve. And my demand comes to be 9,552 new phones. So my demand would increase. Are we all right with this? By the way, with a math video, anytime you need to pause it to write, by all means, you pause it. Let's do one more. So the last one's jointly. I always kind of make a bad joke saying, think Siamese twins. They're joined at the hip. So the next two variables are going to be joined at the hip. So what does jointly look like? Jointly looks like this. K is still the letter, the constant of variation. And the X and W is just whatever. It's the two joints. So we have the loss of heat through a wall varies jointly with the area of the wall and the difference between the inside outside temps. I'm gonna put difference temps. And varies inversely. Ooh, we got a double. So inversely with the thickness. And they just basically want us to write an equation. They can give us a number. So we just want the very basic. So I'm going to put L, A, D, T. Got to clear my letters. So the loss of heat varies jointly. So that tells me, let's make it a cursive L.